scientific notation, ladies and gentlemen, again, if you would focus on the next 10 minutes of your life, you will get many more math problems right than you would have if you don't focus. Because today we're using scientific notation and mathematical operations. And the one thing that you must realize, Ellie Norquist, is when they give you a problem in scientific notation, when they do that, write this in big letters, your answer must be in scientific notation. Because that's where most people go wrong. Okay? They do everything right except the end. They leave their answer in a form that is not scientific notation. Now, there are two things you are going to do with scientific notation. One of them is multiply in scientific notation. And the other one is divide. And I'm going to kind of do them together because you kind of need to see that they're related, but they're not. Divide, you kind of do opposite things as multiply, which makes sense because division is opposite of multiplication. This is an example of a multiplication problem. You may have 1.2 times 10 to the 6th, and then a parenthesis, and then 4 times 10 to the 3rd power. And an example of a division problem would be when you have scientific notation in a fraction form, something like this. 4.8 times 10 to the 6th over 4 times 10 to the 3rd. All right, so you can see the difference there. This one's multiplication, that one's division, makes somewhat sense. Okay. For multiplication, it's a simple four-step process. Number one, this is pretty easy. You multiply the left side together. Which means I do this. I take this times this. What is 4 times 1.2? River, even you can do that. 4 times 1.2? 4.8. Stop me if you didn't get that. I just multiplied together. I don't think I need to do a whole problem out like that or whatever. Step number 2 is you write down, I said I was going to do this together. Let's do it together. How is that different than division? Guess what for division you do? You divide the left sides. Interesting how one would be multiplied. What is 4.8 divided by 4? Anybody get that one in their head there? Anybody? All right, let me do it for you. 4.8, by the way, it's the bottom into the top, is 1.2. Is that what you got, River? I thought you said 2 something. That's good, isn't it, when you... Now, step number 2 is the same for both. You write down the times 10. So here I write down times 10. Here I write down times 10. Step number 3. What color shall we be? Let's go green. For multiplication, okay, the only thing you need to do now is find out what your exponent of 10 is. I don't have that. For multiplication, here you go, you add the exponents together for your new exponent. Add those exponents together. What is 6 plus 3? 9. Thank you. 9. Okay. And over here, guess what? For division, wait, I forgot to write times 10. I'm sorry. This should have been step 1. Step 2 is times 10. Step 3. Guess what division is? Instead of adding them, you subtract them. But you must be very careful, ladies and gentlemen. You are always subtracting the bottom from the top. Okay, it gets a little confusing when they start throwing negatives in here because then when you subtract a negative, you actually end up adding. But you do come up here and you go 6 minus 3, and my exponent is a 3. So this one is subtract bottom from top. And then step 4, what color have we not used? Orange. Step number 4 is you need to make sure your answer is in scientific notation. Make sure answer is I know. Now, this answer, yes. This answer, yes. These two worked out nicely. The problem happens here at River Cabaret and Brady Sovereign is when you multiply these two numbers and you get a number that's bigger than 10 here. We have to do some adjustment, and I'll do that next. Same thing here. Sometimes when you divide, you're going to get an answer that's less than 10, or less than 1, or less than whatever. Then you have to do some adjustment. So let's look at one where that happens. But do you see how they're related? This one you multiply and add exponents. This one you divide and subtract exponents. So here we go. One where you're going to have to do some thinking. All right. Ready? Get set. 4 times 10 to the 4th. 4 times 10 to the 4th times 5 times 10 to the 5th. If I do this problem here and I follow my steps, I multiply the left sides and I get 4 times 5 is, sure, feel free, 20. I write down my times 10. I add my exponents, it is 20 to the 9th power. This, if you write this down on your paper, will be wrong. Because my answer is not in scientific notation, because I am not allowed to have a 20 there. What's the fix, you ask?
What's the fix?
And here's this is the part you just have to get used to doing. Well, the decimal starts here. To make this number between 1 and 10, I just move it back one place and put it there, and I make this 2.0. But I just can't willy-nilly do that without changing some stuff. If I change where the decimal goes in that whole number, you're going to have to change the exponent. And this is where 90% of the people go wrong. Okay? Here is what you must think. You got to think a little bit on the opposite side. If I make this number smaller, I have to add to the exponent to balance it out. Okay, I made it smaller by one place. I add 1 to my exponent, so this becomes 2 times 10 to the 10th. Conversely, well, let's do a division one. If you make something bigger, you're going to have to subtract from your 2. Here is 3.0 times 10 to the 8th divided by 4.0 times 10, I don't know, let's go to the 3rd. Now maybe you can get this without doing a lot of work or not. 4 divided into 3 is, you should be able to tell me because the fraction is 3/4. What decimal is 3/4? 0.75. Let's just go with that. When you divide those out, you get 0.75 times 10. What's my exponent of 10? It's division, so I subtract exponents. I get 10 to the 5th. Correct. Again, my answer would not be right if that's what I put on my paper, because this is not between 1 and 10. In this case, I have to move my decimal 1 to the right and make it 7.5. And again, thinking opposite, I made this number bigger, so I have to make this one smaller by however many I moved it. So this becomes 10 to the 4th power. I will tell you, many of you will miss those because despite the number of times I tell you, you still won't. Let's just practice making things in scientific. Kevin? This one?
Yeah, and also division, we did the 2.0
Yeah.
and 2.0. Why can't you just make it 3 or just like 2?
Why can't I make what, 3?
Just like 2, the 2.0, just make it a 2 or make the 3.0 just a 3.
Oh, it don't matter. You could. I just wrote it down. That's the way the book did it, so I didn't. So here you go. What if I had this 0.0063 times 10 to the 15th power? If I gave you that and asked you to turn that into scientific notation because it is not, what would my answer be? And it's not very difficult, children. You just need to move this decimal so the number comes between 1 and 10, which would put it where? Right here. I end up with 6.3 times 10. What is my new exponent going to be? Remember again, you think opposite. I made this bigger by 3 jumps, so I make this smaller by 3. 6.3 times 10 to the 12th. Or if I had 753.6 times 10 to the 8th power, and I said make that scientific notation, what would it be in scientific notation? Samuel?
7.53 times 10.
But don't forget about the 6. You can't just leave off. If numbers are zeros, you could leave them off, but if they're not zeros, you have to keep them. So yeah, you're going to move that decimal there, and it's going to be 7.536. And 10 to the? Sam, 10 to the what power?
11.
11. 11? How many places did I move the decimal, Sam? 1, 2. I made it 2 smaller, so I make it 2 bigger. So the 10th power. Are you with me? Yes. Are you picking up what I'm laying down?
Yeah.
Are you cooking with canola? Now, just to help you understand why this would be beneficial to you, take a look. If we did not have scientific notation, let's say I had 6.8 times 10 to the 5th power, and I was multiplying that by even 3.1 times 10 to the 7th power. If you really had to do this as a multiplication problem, this is what it would look like. 6, 8 with 4 zeros, and you'd be multiplying that by 31 with 6 more zeros too. Which to you doesn't maybe look that bad, but once you start dealing with all these zeros, you start getting all sorts of crazy things happening. Just because if you're not an organized person, which I would say 75 to 80% of you are not, you are just going to get something wrong because you can't keep all those zeros straight. So scientific notation just takes away all of that messy stuff, and you can just multiply these two together, 6.8 times 3.1, which is 68, 24, 218, 28012, 2 decimal places. You get 21.08 times 10 to the 12th, but I can't keep that. I have to make this one smaller by making it 2.108, which means I add 1 to that, times 10 to the 13th power. If you tried to do this all out with those zeros, you would be fighting for sweating. Guess what, ladies and gentlemen? What I would like for you to do on page 316 is to just do the practice, which is all dealing with what we just did right here, right now, in the midst of the crowd. Just the practice.